Okay, while walking around, a few of you had questions on this one. I didn't see anybody get it wrong though, but I'll just write it. Okay, and again, if I think after I write it, does that make sense? Well, yeah, the fractional exponent is the square root, right? Okay. The only other one I want to look at is this one. Why do you think on all the other ones I gave you all the numbers, but why do you think that on this one I just wrote X? I didn't want to do the math to find out what the number really is. Exactly, James. Because does 5 go into 8? So there's not going to be a nice number that solves that. There's going to be an irrational one, but we'll deal with that a little bit later in the lesson. For now, we're just dealing with nice ones. Okay? Any questions? Okay, because I'm going to build on it a little bit. I know. Okay. So we have in math, okay, I'm just going to write some things up here. You can write it if you want, but mostly I just care if you follow along, okay? In math, there's always something called the identity of the operation. That's just fancy math talk for the invisible one that I always know is there, okay? If I'm talking addition, so I want to know what's being added to the x, what's the invisible number that I always know is there for addition? Addition, 0. Right? Even whether it's there or not, I always know there's an invisible plus 0, right? If I'm asking multiplication, what's the identity or the invisible number for multiplication? 1. What about for an exponent? What's the invisible one that I always know is there? Exponent. No, not 0. If it was 0, it would have to disappear. 1. What about a square root? What's the invisible number on the square root, whether I see it or not? 2. Square root, right? Okay, a log has an invisible 1 as well. Okay? It's a 10. If it's not there and I can't see it, it's a 10. Okay? So if I was going to rewrite this one in exponential form, what would the base of my exponent be, even though I don't see anything on the log? 10. Good.
10 cubed.
Yep. Okay, this one has an invisible log, right? Because I don't see the little number. So what is it? 10. And the last one, 10 again. Nothing to solve on those ones. I'm just rewriting it and trying to explain common log. We're not going to do any of the other examples in that section because it's a section practicing common log, and those are the only 3 examples about the common log, if you notice. So let's move on, yeah? Let's stop, though, actually. Questions? Raise your hand if you have any questions. Nothing? Because you don't know what to ask or because it's easy so far? Easy so far?
Yes, so far.
All right. Keyword so far. Dun, dun, dun. Just kidding. Okay. Now, there's actually 2 special logarithms. The other one is known as the natural log, okay? We have different types of numbers in math. We have numbers called rational numbers, like 2/3, right? Numbers that can be written as a fraction. We have like integers, right? You guys have heard these words before, right? Then we have irrational numbers. Irrational numbers are the ones that go on forever with no pattern, right? Some of these irrational numbers can be simplified algebraically, like a square root 3. Some of them exist. We know they exist. We've proven they exist, but we don't have any algebra to write them, so we have to give them a Greek letter. Those are called transcendental numbers, like you guys care, but I know the vocab, so I have to show off, right? Okay, so transcendental numbers. What's the most common one that you guys have known for years? Pi, very good. Okay, last unit, when we did compound interest, we learned about another one, E. Okay, so just like you guys have memorized always that pi is 3.14. We need you to memorize that E is 2.718. Yeah, you don't need to know all 5 of those. 2.718 is pretty good, okay? But because of compound interest, our PERT equation from last unit, you guys remember what I'm talking about, right? We need a way to solve for the E. So that's where the ln comes in. Anytime you see ln, it's just the mathematician's lazy shorthand way of writing a log base E. So this is just the shortcut to writing this. Does that make sense? So when I rewrite that in exponential form, like the instructions tell me to, I'll say e to the 2.302 is about 10. So log with nothing is base 10. ln with nothing is base e. Okay, I'm going to say that again. Log with nothing is base 10. ln with nothing is base e. Okay? So let's rewrite this one. E cubed is about 20.085. If it helps, you can write the green step. I just hope we get fast enough at it that we don't have to. Couple more? Or you guys can try some on your own. What do you think? Couple more? Okay. So, ln is E, we'll get there, E to the negative 0.69 is about 1/2. Okay, let's look at 4. E is my base. Is E my base because that's E? No, very good. E is my base because that is log base E shorthand.
So E4 is equal to E. Oh, yeah. That makes sense.
Why do you think that one is the only one with an equal sign, not an approximate sign? You got it. There's no decimals to shorthand. It's the exact same symbol on both sides. Let's try a couple the other way. Okay, I'm going to do one the long way. So if I do it like the other pages, that would be log base E of 54.598 is about 4, still equal to my exponent. But the shorthand is there. So on this next one, I'm going to jump straight to the shorthand. Log base E is ln. ln of 0.049 is about -3. ln of 1 is 0. And 8 doesn't have anything written in the log, so it doesn't make any sense.